We actually converted this roller coaster, very amazing story, but he had the LiDAR scanner strapped to his chest in the Disneyland of California.
And we are live. Hi Jordan, welcome to the show.
Peter, thank you for having me.
Excellent, we finally made this work. It took us a while to arrange it, and against all technical odds and technical issues, we are here, so happy to have you.
Thank you for having me.
Excellent, so I guess the starting point of this discussion would be to talk a little bit more about what you guys do in terms of solid clouds and the drone technology and the 3D cloud as well. So let's start with that.
Yeah, so we actually started in solar. It's a long story. I'm actually a civil engineer and business economics in my background, and I worked a couple of years in the construction industry. And in 2017, I rejoined the renewable sector. This is where they needed somebody to help with the structural of the building that was strong enough for the solar panels, and somebody that had experience with AutoCAD. Long story short, after lots of headache, we'll go into the details, about issues pertaining to the industry. But found out that you could actually scan buildings with drones, and also discovered stuff like Media that provided you high-resolution imagery of roofs. And we were still designing in 2D, and somehow I came across VertoCAD as well. At that time it was called Virtual Solar. And we actually found a way to convert that point cloud from a drone scan into a 3D model that the Virtual Solar would recognize and that we can do the engineering, which saved us a lot of time by measuring it ourselves or using Google imagery that was lower resolution. And after the company was sold, I kind of developed this process internally, how to do that. He and the director started SolidClouds. So my old boss became my business partner, and we actually started selling it as a service to competitors or other developers and EPC companies. And before you know it, we had reached the construction industry that does the roofing of the buildings. And they said, hey, can you also do this for the roofing? We said yes. And then we did a large facility where they also asked, hey, can you do the inside? And that's kind of how we have 3 different clients now: solar, construction, and manufacturing. But pertaining to our services in solar, we do thermal scans. We're an official reseller of services from Sitemark. So this includes thermal scans, construction, monitoring. And so these are services we provide for the solar. Loose from that, these same scans we use to create as-built drawings. Like you see that oftentimes that the final as-built drawings aren't available. So what we do is we scan it, we recreate it in VertoCAD, and then we create the PVSys files for analysis and see if it's actually matching the true output. And in some cases, we even done 9 sites where the as-built weren't delivered and the site wasn't producing the yield according to the contract. So they wanted to find out what the issues are. So we then did that. But where most people know us within the solar is for the conversion of roof data to 3D models. So our speciality as SolidClouds is that we convert point cloud data. These are like, for those that don't know, they're like 3D measurements of a building represented in different points. That's why they call it a point cloud. The name Solid Clouds refers to point clouds, and we make a solid from those clouds. And from those point clouds, we actually convert it into a 3D model that different solar engineering applications can understand and that they can start modeling on top of it. So
maybe just to explain to those of the listeners who are not engineers. So basically, when we are talking about the 3D point cloud, the typical issue is that you come with the drone scan and then you need to make a design to understand it correctly and understand how the topography works, etc. And if you do not work with you guys, then you can build that 3D point cloud manually, but it's going to take you a long time. And it might or might not be accurate. But if they do work with you, it's going to be more efficient and basically it's going to be more accurate as well. And their software will understand the output.
Yeah.
Am I correct in the explanation?
Yeah. So you can make your own point cloud, and there's different companies that do drone surveys, and they use a technology called photogrammetry, which actually means like recreating a 3D element by using photos by understanding where the positions of the photos are, so it can understand what it's looking at and then recreate the surface. So there's a lot of companies that do that, but our speciality is converting that simple scan, lack of a better word, but into a model that is understood by the application natively. So it will recognize, like VertoCAD recognizes our roof surface as a roof. So then when you start modeling your PV panels, it will be able to place the panels on the roof surface. It will also see that there are obstacles on the roof, like HVAC systems or any piping or fencing or whatever. And you can automatically then add distances to those elements, then avoiding those areas when it places the PV panels on the roof. So that's where we come in, and we understand these different applications. We serve a wide range of applications like VertoCAD, PVSol, PVSys, PV Complete. So we create these models for them, and every one of them has a different way the 3D model is built up. One just needs a flat plane for the roof surface. The other one needs a box with a roof-shaped surface. Depends on the application. Yeah.
So each tool has their own different requirements that you need to tweak a little bit so they can recognize the actual drone scan.
Exactly. Well said.
Excellent. And so, but we discussed prior to this chat as well, we were talking a little bit more about the structural side of things as well. So you guys provide the solar solution for the drone scans and the conversion to be able to convert this into an engineering design. But the second part of your solution is actually looking into the construction underneath it as well. So can
That's
you
correct.
speak to that?
Yeah, definitely. So, the engineering is one part, but actually knowing if the roof is strong enough is another part. So what we actually do is we have a mobile scanner. It's a Navis VLX. It's like a backpack scanner. And we walk around pretty much. We could do about 600 square meters in 6 minutes. And we scan everything about 5 millimeter accuracy. And with this, we then recreated as well the roof structure, and that can then be shared with roof and yeah, how do you say that in English? Anyway, the companies that does the structural analysis of the structure, and they can then determine if the roof is strong enough for the solar panels. So this is also, I've been in the field, I've actually been on site having to measure these structures manually, and it's a lot of work. You can easily be 2-3 days for one building busy measuring. You need to make sure that you're communicating with a client, that the site is, that you can reach the laying beams and etc. So it's time consuming.
And of course, I can imagine it also racks up the costs as well. Time is money.
Yeah, definitely. Like also for safety, you need to go with two people because you have to go on a platform lift, and there always needs to be somebody. You could have, for example, a heart attack up there and you were stuck up there. So needs to be somebody there as well to be a support there for you. Yeah.
Makes sense. And so we talked a little bit about the kind of rooftop types of projects, but we also talked a little bit more about the ground mounted projects and the solutions that you guys offer in that space. Can you speak to that?
Yeah, definitely. Yeah, pertaining to fields, let's look a bit at the alternatives. Like, how do you measure the site? What are your ways of measuring the site now? How do you access the site? Is it grown with vegetation? How do you actually look and see the site? How do you make sure that you're within the boundary lines when you're actually building the site or doing the stakeout? All of these things require, at the moment, traditional methods using total station, using your phone, taking pictures. So what we provide there is also the same tools with photogrammetry or with LiDAR. We can then scan the terrain and actually have it in the correct geographical space up to 2 centimeter accuracy. And this then can be used for the engineering to assess the site curves. Also do slope analysis. So we'll be able to detect from that surface what is the degree of the slopes. In some cases, you're
Very
talking about
important.
like a waste mountain, for example, that you're not allowed to move the soil off of the terrain. So the soil has to stay on the terrain because it might be contaminated in some way. So we can then, by doing the slope analysis, determine, where can you extract some soil and place some soil to create more equal planes. And the more equal planes you have, the more dense you can
Easier
create
it
your
is.
PV systems. And so these are types of things we do for the field. Also the same services, of course, from SiteMark, which are thermal scans, and for already existing building site and construction monitoring.
So you guys are also able to calculate cut and fill type of functionality. So basically to determine where you need to remove soil and where you need to move it to.
Yeah, correct. Yeah. It's quite easy. Once you have the point cloud, we don't even need to do a conversion. We can just do it from the point cloud itself. So that's very powerful. We really believe in multi-purpose of a point cloud. You can really
Indeed.
use a point cloud for so many things.
Indeed, and I guess for your clients, for the project developers and the EPCs, this is hugely valuable because if you can determine, the slope or where you need to move, you can determine the cost of, moving that soil before you even start placing any panels. And then you can also determine the limitations where, for example, the piling machine cannot go over, I don't know what the degree is, but it's not a very high degree. It cannot climb a mountain that's very steep.
Yeah, but also for site management, right? Site design. Where are you going to put your containers? Where are you going to put your material? All of these things. Also, Google just doesn't cut it yet. It's the resolution is low. You don't always know what you're looking at, and also in practice, there's also a deformation. So you have sometimes a meter extra or a meter shorter. I recently saw a post from Omar that they needed a meter between a fence and they didn't have it for maintenance. And yeah, those type of issues you can then get, of course, if you're not careful.
Yeah, it does happen, and I think there are different data providers like Cesium, Airbus, etc., who give you like a bit more granular data and with higher resolution. But the drone scan is the most accurate you can get so far.
Yeah, because even if you do use stuff like cyclomedia, things could change within a year. Those pictures, it takes a year to get it, and you don't know if you're at the beginning of the year or at the end of the year, and stuff might have changed. Also, the resolution, I believe it's at 5 centimeters or 8 centimeters, something like that. So with a drone, you can go a lot deeper. You can really see even like just use an example of a waste mountain, but even like some of these tubes that you can barely see, you can still see them with a drone scan.
Makes sense. And what's the craziest projects that you guys helped so far in solar?
In solar, okay, good that you specified. Yeah, the one of the craziest ones we've done, which was quite challenging, was a greenhouse. As a greenhouse, because photogrammetry doesn't scan glass. And LiDAR also doesn't scan glass. So we had quite a bit of a challenge to be able to scan it, but we use this new technology called 3D GIS, which stands for, it's a neural radiance field. And this kind of captures the glass a bit better. And so that's what we use to be able to then recreate the greenhouse for engineering. So that's one of the craziest ones. I would say those 9 projects I was mentioning before as well, those 9 projects with quite a tight deadline. And yeah, there went a lot into it. It was drone survey. It was recreating it in Revit first, then converting it into a model for Virtuous CAD. Then, of course, putting all of the line diagram, all of the strings set up and the inverter setup, etc. And then actually creating the PV syst and actually checking, okay, which part of the lack of production comes from the system to system shadow, which one comes from the trees in the surrounding area, and then actually being able to determine at what years, at what month, what affects more, and then able to determine
Nice.
which trees need to be removed to have the most benefit. So it was quite an intensive project.
Oh, that's very cool. And now we spoke a little bit about, we are jumping a little bit back and forth along the project lifecycle. We spoke a little bit about pre-construction, post-construction, operation and maintenance. So can you walk us through what type of solutions do you guys offer at each stage of those life cycles?
Yeah, so at the beginning, I would say a developer starts the talks with a client, an ex-client. You want to already have a type of initial design when you're talking to a client like that to say, hey, this is about, this could be possible. And actually being in the field and seeing the effect at the end, we used to do it in AutoCAD 2D. The moment you have a building next to it, which is slightly higher, you already have an effect on your business case because of shadow. These things weren't considered. Now, we could be thankful for programs like PV and PVSys, Virtual Cat, and among others, that they allow that information. But to start with high cost with a drone already at that phase while you're not sure you've closed the deal is overkill. So they don't have any other options. At least they think. So what we actually provide is most of the countries here in Europe actually have an open source point cloud that gets produced by the government. So if you're wondering where your tax money goes to, well, here you go.
We found it.
So
We
you
found
actually
it.
have yeah, so you actually have a high quality point cloud up to 15 centimeter point distance, and I'll show a point cloud for those that have been wondering what that is. But with this point cloud, you actually have a good enough base to model a rooftop in 3D that they can use that is will be very closer to their business case than if they traditionally use just a 2D design. So maybe I could just share that quickly and we can have a look. So here you go. So here's a point cloud. So it's what you would imagine it would be, some points and the kind of it's grouped together. So kind of look like a cloud. And so you can also see already some objects. Now, of course, the distance between the points, I believe, as I said, was about 15 centimeters or something like that. So everything smaller than 15 centimeters won't get captured or will very poorly get captured. But you do know in some cases, something's there, something's there, something's there, and it's about this height, right? So we use these models then and convert it into a model for PVSol, VertoCAD, etc. And then they have a good idea of also shadow elements, right? If you're building on this roof, you have this roof here, so we can recreate this building as well. And when you're doing your initial shadow calculations, it will also take this into account, which is very powerful for your business case. Then you actually know what you're selling.
This is a very complex building to put any panels on.
Yeah, somebody's got to do it.
If your software can manage that, it can manage anything.
Yeah, indeed. And as I said, it's a whole country scanned. So the Netherlands does this every 4 years. They scan the entire Netherlands. And Belgium does this as well. Germany does this. I believe Switzerland as well. Sweden, Norway, they all have these collection of data. And loose from that, you also have companies like Cyclomedia that actually also scan the country and also provide point clouds from the street and from the sky. So if you're already a client from Cyclomedia, you could probably make use of this within your subscription. And if not, this is all free. For those interested, it's called Actueel Hoogtebestand Nederland. The short name for it is AHN, and they even have the 5 now, but it's not fully available yet.
Very cool, and we will link to that in the show notes as well. But so essentially what you're saying, if you're a savvy developer, you just go to this website, you can find your locations that have some potential, you can contact the owner, and your sales funnel is actually being filled up.
Yeah, and indeed. Yeah, you can measure if you don't use our service that's minimum, you can use it to measure heights and distances. It's a laser scan. So and yeah, this is no cost to us, right, to acquire, and all you would be paying for then is the conversion. And once we convert it, you can use it for your design. So that's the first phase. Once it becomes more contracted a project, you want to start looking at other things. You really want a more detailed look of the quality of the roof, right? If they need to maybe do a roof maintenance before they actually start installing the panels, or you need to check the structure if it's strong enough. So those are elements we also assist in by utilizing a drone survey, for example, for the roof quality, and using our Navis scanner for the inside to scan the structure. If there are drawings available in 2D CAD as well, and you need to create it in 3D for a construction analyst, then we could also create that from the 2D CAD drawings. Once everything is contracted and you actually have, for example, a field and you want to create renders or even from the roof, we also support there. We create the high resolution renders. Maybe you could, Peter, showcase the video from every point that we did using just an iPhone scanner for small buildings. So maybe that's a fun thing to
Yes.
know, but you can even use your iPhone to these days to scan. And so if you're a house owner, you can even use your iPhone to scan your house and create something like this.
And again, it already makes sense at a smaller scale as well for even a residential building, not just from commercial and industrial.
Yeah, definitely. Especially people that don't have the know-how, right? If you need to if you can send this of your house to somebody that does the engineering, right? You won't need to plan an on-site visit. It's a lower carbon footprint, right? It's environmentally friendly. And since it's small, your iPhone would do a pretty good job. It might have some issues with scaling, but not at such a scale that it won't be usable. And you can immediately see which roofs are the most interesting to put place panels, right? And that's the most important part. You would hate to just have somebody sell you as much panels as possible, and some of them won't be even producing any energy, so it's a waste. And then you'll say, these panels, they don't provide any value. Yeah. So
Makes
it all
sense, and
starts
also
at the
comes back.
beginning. Yeah.
Indeed, and it also comes back to the carbon footprint, right? We don't want to put panels that are not working, and on the cost side, and also on the carbon footprint side.
Exactly.
And you mentioned something that triggered me a little bit is the AR VR type of side of things. So I assume that technology is widely available already. To what extent do you guys utilize that?
So that's mostly once you already have, like in the Netherlands, you have participation. You need to participate. You need to have the people that are living in the area participate in the approval of your site. And so you need to be able to sell this. And for those that have experience, selling a PDF with some squares on top of it doesn't do a really good job at conveying the idea. But you can make a PV plant look nice, and this allows as well for easier acceptance. When you understand it, when you can see it, you can believe what it's going to look like. And so we also help with that. The same model we use for 3D engineering, we can use just adding texture to it, adding some trees, and we could render it and then also create a VR walkthrough. So we can create 360 degrees views. I'm going to send you a link for a project we did, Peter. But then you actually have a VR, you put it on, and you can also put it in specific positions because you might not have everything thought out, right? You might not know exactly how you're going to do the landscaping. So you can also choose specific places you will stand and have like a 360-degree picture, rendered picture that you can actually look around. And that way you can control what they're actually looking at and create the perspectives you want your client to see.
That's super, super powerful, especially to the people we mentioned before. If I am an asset owner, I'm not going to dig down to the engineering side of things. I really want to just see and conceptualize, especially at an early stage, of what my project might look like, how many panels might it take, what should it produce. And I think this is really powerful for the people who are not super technical or not super zoomed in on the design element of the project.
Yeah, but people are set up that way that they can't understand a 2D drawing. What will it actually look like in 3D? And it helps. It is the future. Everything is getting 3D. You have these self-driving cars using also LiDAR technology to navigate. Before you know it, everything will be scanned.
Indeed. So the next step with this project would be, what would we be doing?
So yeah, once you have the rendered parts of it, and let's say you need a soil analysis, if it's a field, we also do the design work itself. Once the design work is done, we provide also the PVSys. These are the calculations of the production of the site among its life cycle. And once the project is actually going to be built, we actually do the stakeouts as well. We can put the stakes on the site so that you know exactly where you have to place your piles. And we also provide construction monitoring, which would actually mean that at specific milestones, we would do a drone survey, and you can compare it then to the engineered model to see if, the piles are placed also in the correct place, if they're started at the correct space, if the spacing between them is correct, if the angle of the placement of these piles are correct, which is one of the most common issues on large solar fields, is that the pile distances start to change, and 1 centimeter here is 2 meters at the end. So this, um, it's definitely undersold at this moment. I think the industry could benefit a lot from using this, because even if you have a project manager there every day on site for a large site, like small site, sure. But if we're talking about 120 megawatts, 160 megawatts, 200 megawatts, you won't see these issues before it's too late.
Yeah, of course. I mean, the as built and as planned is sometimes two different things.
Once that's complete, and you've actually done a construction monitoring of a site, we also, as I said, in some cases create. So once the construction monitor has actually been done, and in some cases the as-built has not been delivered by the EPC company for whatever reason, we can also produce the as-built based off of the design and the drone scan and the site, the actual site. So we combine those things together. We also use the weather station data's information to then create an accurate analysis of the production of the site and be able to determine what effects of shadow there could be or any other issues that could have an effect, for example, a hotspot on your total production. And we create different scenarios where we can then see which one has the most effect for improvement. And then it's up to the client to then remove a tree or,
Makes sense. And where do you see this technology heading in the future? So right now we are able to scan how it looks like today with quite granular accuracy. We can work with that file once we have scanned it with different types of design tools. Where do you see this in 5 years?
Well, I already see quite some changes with these docks from DJI. I think that is very powerful that you have a drone there to constantly inspect, that you can constantly check thermally if the system is correct. I think that's already something very powerful. Pertaining to my field and what I see is oftentimes bottlenecks are time. Time is oftentimes something that, because of the way we're working now, is kind of recklessly used. That's what I feel, at least. Having to design something currently, how it's my understanding of how it currently goes is that you have developers, they design an initial layout. This initial layout gets used for communication with the client. If it's 2D, you already know where I'm going with this. There are effects of shadows, etc. Then you'll have to contract the EPC company. There's a selection there once you have an initial contract with the client. Then you start looking at substructure manufacturers, and then they'll actually tell you, hey, what you modeled here doesn't work. It has to be like this. You modeled south, we have to actually do it east-west. You know what I mean? Or you modeled with a 1 meter spacing between the tables. We actually need a 2 meter spacing between the tables. And that's re-engineering again, recommunication, new contracts, change to your business case. Maybe the business doesn't make any sense anymore. And then, you're pushing all of these costs up for later instead of making the cost up front. And it's going to cost you more at the end. It might cost you the whole project, So where I see this going in the future is that you will have an application that has already all of the parameters of the substructure of the different systems for fields, for example, and the developers can use this tool and pretty much pluck anyone from the street and put them behind a computer and say, hey, this is generally how you plan a site, and hey, he just has to drag and open up, and it will automatically take all of the parameters of the structure, designing something that is really able to be built. And of course, there might need some adjustments might be required at the end, but the difference between what's happening now and what I'm proposing here is that, it will be a lot more accurate. Plus, from that same model, you would be able to generate immediately a rendered model, and the EPC company can continue with this design, and this manufacturer can also continue with the same design, not having to redesign it at every phase. Developer, EPC, and sub constructor. Yeah.
So basically, in other words, if the tools become more user friendly, the barrier to entry to the design process itself, it should be a bit easier, right? Because more people will be able to complete a more or less complete design due to the ease of use of the tool. And then we will also have more accuracy in terms of the data and what we translated from the real world to the digital twin, right?
Yes, definitely. Like, you know, there are applications out there that use these parametric design. You can think of Grasshopper, Rhino, these type of applications. And it's actually just putting limitations on the 3D elements, saying, okay, you can only go this far. You can only add this much. You can only tilt this way. You can only, and having these limitations does the thinking for you. So that means you don't have to do that thinking anymore. You can even push the knowledge and simulate the substructure of the manufacturers. You can even push it to limits they haven't tried out yet. And you can even do the structural analysis on these models. So, having the thinking done for you, we're going in a time of AI where you now use it to help you write your emails, right? And later it will help you design your plan. And that's where I think it will be going. Once you have those parameters in there, it will increase the time to build. And that's what everybody wants. Everybody wants that the process is smoother and the process goes faster. And there's only one way to do that is if it starts off well. If you start off not well, you'll have to pay with time or with money at the end.
You can build a castle on sand, but it's not gonna last long.
Exactly. Good saying.
Let's jump and talk a little bit more about you guys as a company. So we talked about the product and quite technical stuff already. So I'm gonna make a note here. So if we talk about you guys as a company, how does Solid Clouds look like today? How many people are you guys? What markets are you covering?
Yeah, so we're now about 7 people strong. We are existing now for 5 years. We're a bootstrap company, and we're now in conversation with a company for acquiring some of the shares. So at the moment, no venture capitalists yet, but slowly, hopefully getting them on board. Yeah, certain markets we serve, as mentioned, ours is solar, construction, and manufacturing industry. So for the solar are the services we've already discussed, and for construction we are mainly involved in renovation projects. So when there's no drawings available of a building, or if they have drawings, but once they've done their initial site visit, they notice that, hey, it's not accurate. They hire us to scan it and to convert it into a BIM model. And this BIM model is then used for the new engineering. We also do for the manufacturing, we do also the same thing, mostly in cases where they need to replace a machinery or know if something is going to fit inside their plant. What we actually do is then also do a scan of the site, create a BIM model again, and actually do collision tests and actually remove the piping virtually, add the new piping virtually, and actually see if it's going to fit, if we need to reroute cable trays or piping. And we also create a PNID, which is kind of like a piping identification diagram, which is kind of like a line diagram of what piping is where and what valve does what. Yeah.
So you guys really complete the whole workflow.
Yeah. Yeah, definitely. Yeah. The great thing is that we kind of utilize the same tools. Yeah, for roofing companies, for example, we also do for real estate corporations. They call it a zero measurement, which actually looks at the quality of the roof and categorizes the roof according to its status. If it needs direct maintenance in 2 years or in 5 years, or it's good for the next 10 years. And one of the questions is also, hey, can solar panels be placed on the roof? So that same point cloud, we use it again with PVSys, and we can analyze it and see which areas of the roof are more suitable for solar panels, up to 10 centimeter cells.
Wow. And since we are talking about product, let's talk a little bit more about product building. So what's your mantra? What's your methodology when it comes to building new product lines and how you approach these things?
How we approach them. It's mostly how I guess we're still young, so we have the luxury of exploring. So when a client comes with a unique request, we take a hard look at it. That's how we start. See if is that something we think we could achieve. If we can't achieve it alone, can we achieve it together? We believe in working together with partners and even clients in some cases. Some clients have helped us with other projects. So, and then we assess, okay, let's try and do this. Let's do it as a pilot. And yeah, in short, we do a lot of pilots. Yeah. And if we see, okay, we were able to do it and efficiently, we actually then promote it to another client. And then if it takes off, it takes off. That's how we currently do it.
So still a very lean startup methodology.
Yeah. Yeah.
And I think it also begs the question of when do you say no to the clients? Like how do you identify, okay, this is not for us, this is not exactly what we are, the direction we are going to?
We've been able to build that feeling. I would have to say at the beginning, and it wasn't that way at the beginning. I guess maybe other entrepreneurs can relate, but you kind of just happy to do business. But as soon as you start taking on some of these pilots and some of them cost you a bit more than you would want it to, you start getting a feel for, okay, this is something we could make happen and this is something we can't make happen. And so I guess experience is how we kind of are able now to say no to specific requests.
Nice. And on that note, who inspires you as an entrepreneur?
Oh, so many people. I like a lot Alex Hermosi. I must know him. I follow a lot of his stuff. I also read here. I don't have the time to always read, so lots of audiobooks, but Never Split the Difference, Persuasion, Question-Based Selling. I had to develop my sales skills because I'm actually more like a technical guy, so sales is not my caveat, but I had to learn it. But so, yeah, I would say Alex Hermosi is one of the key people I follow at the moment. There's other people I also listen to, but not as often.
And was there any intrinsic motivation for you to dip your toes into renewables, or it kind of just happened?
Yeah, it kind of just happened. I just finished working for a natural stone company in 2016 and was looking for something a bit closer to home and got this job. Rooftop Energy was the name. Now they're called Groendes. Yeah, it was a good salary at the time for me and also a young company, so I could have my imprint. I liked the idea of being to add something to the company. And so, yeah, kind of dove in and kind of fell in love. I liked the diversity of it. You also have quite a diverse, even though you think it's simple solar panels, but floating, you have different types of roofs, different types of substructures and different challenges with every build. So, and it kind of got me into drone technology and GIS and and that's how it kind of rolled into SolidClouds. It was kind of a natural process, I would say.
Makes sense. And from what I heard, most people, especially in the drone space, they start with flying the drones, playing around with them, and then they actually realize that they do have a solid business application as well.
For me, it was the other way around, seeing people flying and then going at it
Getting
myself.
getting more and more interested. And you guys are based in Holland. What are your core markets in terms of geography? Are you focused purely on Europe, or do you also do projects across the globe?
Our focus in sales is really national, and I would say the direct neighbors, which is Germany and Belgium. But we've already done so much abroad as well. We've been to Tunisia for our glass production facility. We've even been to Aruba for 9 projects. Somebody had to go, so I offered. Yeah, I took one for the team.
Okay.
But we've also been in Greece. We've done projects in Norway. We've done projects in Spain. We've done in Luxembourg. So we really are doing projects all over. But our focus is still direct area. We've even done a project, how can I forget, in the US for Mark Robber. But for the company that actually provided the LiDAR scanner. We've worked with them before. We've converted a roller coaster, so maybe you could show something of that on the screen. And also the full video is there. But we actually converted this roller coaster, very amazing story. But he had the LiDAR scanner strapped to his chest in the Disneyland of California in the Space Mountain roller coaster. And while he was in the roller coaster, he actually managed to scan it, just having the scanner on his chest. And that scan, yeah, and it's pitch black in there as well, so you can't really see much. So the scanner does pick up everything, even in the dark. And we converted that into a 3D model, and then converted that 3D model again in a 3D model for printing. And they actually printed it out in 3D, and actually we helped recreate a dream of Mark Roberts since he was a child. So that was very cool.
That's a very cool case study, and I hope there was no accidents happening on the roller coaster.
And no drone flying. Luckily, it was strapped to his chest.
That's cool. And what's if people wanted to talk to you or Solid Cloud, what would be the one ask that you would put out there in the world? What would you guys be looking for from the audience?
Do you know Solid Clouds?
Good qualifying.
No, I wouldn't know what to ask at this point. I think I'm a bit in my own bubble at the moment. So, but that's a good question to think of. I think let me give it to you so you can add it to the description, and then we have a reason for them to look in the description.
Perfect. And along your journey, what do you guys expect to or hope to achieve this year? I mean, it's been quite turbulent for solar, and you guys also expanded into other industries as well. Where is your focus this year?
So we've noticed that for us, we still are active in the solar, but not as active. And we still have our fixed clients that we constantly do work for. But our focus has shifted now more towards the manufacturing industry since there's more happening there. The demand is higher, so efficiency needs to increase. Not everywhere there is, due to grid limitations, there are not everywhere you can scale in size, but you have to be more efficient. So people are really looking, investing into improving the machinery they have into more sophisticated ones. And so that's our focus for this year. Also, not in too far future from now, I do see splitting Solid Clouds into different Solid Clouds. You could say Solid Cloud Solar, Solid Clouds Construction, and Solid Cloud Manufacturing, just to make it a bit easier also to understand, okay, what the Solid Clouds actually do and where do you have to be to get specific services. We're also looking into maybe opening a Solid Clouds Germany, just so we can more actively and aggressively approach projects in Germany. And yeah, for now, it's more focusing on being acquired by a new shareholder. Once we have that, more as possible.
Very cool, and crossing fingers that the transaction goes the best possible.
Thank you.
And when it comes to people reaching you, what would be the best way to reach out to you?
I'm available on LinkedIn. You just send me a message and I'll reply. Either way, it doesn't matter what the question is, I'll reply. Keep it PG-13 though.
We'll link to your LinkedIn as well. You're very liberal with this.
Yeah, so LinkedIn is the number one place to reach me, or you could always send an email to the info@SolidClouds and they'll send it over to me.
Cool. Jordan, any final thoughts?
I just think that there's a lot going to change in the coming years, and you or change with it or you're left behind. So I would say if you're not known yet with some of the things we've mentioned here, I would say definitely take some time to just look into it, because it could really change the way you work.
Everybody should buckle up, survive the year 2025, and hopefully we are back on the exit velocity on 2026.
Definitely. Thank you, Peter.
Thank you, Jordan. Have a great day. Speak soon.
Bye-bye.